Hey folks, today we'll understand memoization in JavaScript. So without any delay, let's get started. First of all, what is memoization? Memoization is a technique using which we store the result of a computation in memory, so that if that computation is being called again, we could simply fetch the result and use that result instead of executing that computation again and again. We do this for expensive computations. What do I mean when I say expensive computation? The computations which takes time to do the processing. For those computations, we store the results in a memory instead of calling that computation again and again or calling that function again and again. And yeah, that's all memoization is. Now let me show some examples so that you could understand better. Okay, let's write a function. Let's write a function to get the square of a number. So I'll say function square, and here I'll instead of like multiplying the numbers together, I'm writing a for loop. No, we'll get number here, and here I'll do let I equals to 0, I smaller than num I plus plus, and then simply I'll first say let result is equals to 0, and here I could then say result is equals to result plus num, and finally I'll return the result. Okay, so that's how we'll get the square of a number. Let me check quickly whether I'm getting it or not. Let's check the square of the number 4. Okay, so I'm getting 16 in the console. You can see here in the console. Okay, now instead of 4, let me check the 20, square of number 20. Okay, so we are getting the square of numbers here, so this function is working. Okay, now let me show you how much time this function is taking to execute. No, so for that I'll do console.time. It will simply give you the time period that is being taken for this function to do the processing. Okay. Now here you can see it is taking around 33 milliseconds to get us the square of 20. Okay, that's cool. Now what if I want to do the square of something like a big number, like this? Let's say how much time it is taking. So the number I took is quite big, that's why it is taking more time than expected. Okay, so it is taking 9858 milliseconds. Okay, that's clear. Okay, so every time I calculate the square of this number, it will take this much time every time. No, so let's just shorten this number a little bit, and if I do this again, then again and run this, you can see that at every time this number will take this much time, around 1000 milliseconds it will take. No, this time will vary a little because there is some processing going on inside your system also, in your system also. So yeah, but majorly it will take around 1000 milliseconds. No, every time. Now we'll use memoization to reduce this time drastically. So how we'll do it? We'll take an array, we'll say just const arr an empty array, and what we could do here is first we'll check, and don't worry, I'll make you understand what I am doing. First let me just type it out. First we'll check if anything exists here. If there is, then we'll simply return arr num. We don't have to do any computation. We'll simply return this thing, and then let me just comment this out, okay. And if it did not exist in the array, if the result does not exist in the array, result of the square of the number, what we are storing essentially in the array, at the position 1 will storing the square of 1, at the position 2 we are storing the square of 2, at the position 11 we are storing the square of 11, and in between all the values will be undefined, okay. So yeah, that's what we are doing here. And now what we can do, okay, we can say if this won't work, that means the value of this number at this number index, there is not the value is undefined there is nothing stored there, no. So we will store it if we are calculating it for the first time, okay. If we are calculating the square of a number for the first time, we will store in the array. So we will simply say arr num is equals to result, okay. Yeah, this is what we will say, okay. So that if we have calculated the square of a number, we don't have to calculate the square of that number again and again, okay. So now let me just uncomment this, and let's see what happens. See, you can see the first time that the square is being calculated, it took the same amount of time, around 1000 milliseconds, but afterwards we get it instantly, in only 0.03 milliseconds, 0.02 milliseconds and 0.04 milliseconds. So why is that? Because in the first iteration, in the first case, we have to calculate this thing, we have to calculate the square, but for the next iterations, for the next time when we run the function, we don't have to calculate it, we will just pick the value from the array, okay. So it will so what is essentially happening is the value is actually stored, the value of the square of this number is actually stored at this position. So it will simply pick it out from here, okay. So yeah, that's one use case of memoization. And second use case is in case of fetch calls, no. So we don't have to perform the same fetch call again and again. If it is taking time, we could simply store the result of the fetch call in the cache memory, and whenever, instead of doing that fetch call again, we could simply use the result, okay. That's the second use case. And there is the third and most important use case where the memoization is used very frequently. So let me just remove all of this. You understand this, no? Okay. Now the most important use case is recursion. Yeah, in recursion. So if you don't know Fibonacci series, you must have heard of Fibonacci series. If you don't, let me just quickly tell you. The default value at 0 is 0, the 1 at 1, and afterwards the value at a position in Fibonacci series is the sum of the previous two values, So value here will be 1 because 0 plus 1, value here will be 2 because 1 plus 1, value here will be 2 plus 1, that is 3, value here will be 3 plus 2, that is 5, value here will be 5 plus 3, that is 8. So this is Fibonacci series, okay. So the value at a particular index in Fibonacci series is the sum of previous two values. Let me reiterate, value at a particular index in a Fibonacci series is sum of values in the previous value at a particular index in Fibonacci series is sum of the previous two values. As simple as that, okay. So let's write a function to calculate value at a particular index in Fibonacci series. So we'll say function, let me just call it Fibo, and we'll take num here and we'll say if num is smaller than 3, this is the the default case, no. So will simply return 1, because Fibonacci of 1 is 1, Fibonacci of 2 is 0 plus 1, that is still 1. Okay, so if number is smaller than 3, simply return 1, else return Fibo of num minus 1 plus Fibo of num minus 2. So yeah, in this way we can calculate the Fibonacci at a particular index. Okay, so let me just show you. Let me just calculate Fibonacci of, let's say 10. Okay, so we are getting here 55. Okay, now let me calculate the Fibonacci of a larger, in this case, no, what is actually happening. Let me just first let us calculate the Fibonacci of 50. Okay, so this is taking too much time. You can see that here this is loading. So yeah, so 50 is a large number to calculate in case of recursion, in this Fibonacci recursion. Why is it so? I will just explain you in a few moments if after getting the result here, but I am not getting the result here. So let me just comment this out and just again open up a live server. Okay, so instead of doing the foolish thing and calculating the Fibonacci of 50, we'll calculate the Fibonacci of 45, because it increases exponentially even if we increase the number by 1. So I hope it will be calculated soon. Okay, so finally I got the result here. It is 113 or something like that. So it's a large number. Okay, and this is how we calculate the Fibonacci of 45. And for the reason that why is it taking so much time, here is something I draw. Yeah, if let's say we wanted to calculate the Fibonacci of 7, in that scenario you can see we have to calculate the Fibonacci of 4 like 3 times, 1 2 3, and Fibonacci of 3 1 2 3 4 5 times. So that's how many times we need to do the calculations. But instead of this, what we can do is, when we are calculating Fibonacci of 3, we can just when we are calculating Fibonacci of 3 for the very first time, we could store the result in the array. And when we are calculating the Fibonacci of 4 for the very first time, we can store the result in the array, okay, at the corresponding index, so that we don't have to calculate the Fibonacci of 3 and 4 again and again. Every time when our function needs the Fibonacci of 3, we could just fetch the result. Every time when a function needs the Fibonacci of 4, we could just fetch the result. So yeah, that's what we can do. It will this is a very expensive operation, no? So it will make it like much more efficient, because this is the Fibonacci of 7 is still a very small number. That is why you are saying that when we were calculating Fibonacci of 50, our browser is getting loaded, but we were not getting the result, no? Okay, so yeah, so let's do that. Let's make an array and we'll store the result of the Fibonacci of a particular Fibonacci at a particular index if that is being already calculated. Okay, so for that, what we'll do is we'll pass the array equals to an empty array here. Okay, so we'll pass the empty array here. Now first we'll check. First we'll check if ARR of whatever the number we are giving is not empty, that is, if this is like not undefined, this ARR of num will be true. Okay, so in that scenario, just simply pick up the result and return ARR of num. Okay, simply return the result. If Fibonacci of 5 is already being calculated, you don't have to calculate it again and again. You can get the result at ARR braces 5 inside that fifth index. Okay, so yeah, array indices starts from 0 and we'll get the result at fifth index. Okay, first do this. Let me just comment this out. Okay. But then let me just do here else if, and okay, here else. Now here, instead of returning 1, if the num is smaller than 3, do result is equals to 1, and let's define result here. Let result, so define result here. First we are checking if already we have calculated the Fibonacci of that particular number. We'll simply pick that up from the array and return it. If not, then first we'll define the result here. Its value will be undefined initially, then here it will be equals to 1, and here it will be equals to this. Result is equals to this, and instead of doing num minus 1, we'll also again pass the ARR, and here also we'll pass the ARR, so that loop continues. No, that recursion will happen. And finally what we'll do is like if we are not returning here, that means result will be either equals to 1 or result will be either equals to 2. Whatever the result is, that is not still being stored in the array, because if that was stored in the array, we could have returned it here only. So let's store in the array. So we could say, so that next time if this number comes up, we could just pick the result from the array and give it back. Okay, so we'll store the result here in the array, and finally we'll return the result here. Okay, so yeah, I hope this will work. So now what will happen is, if so now I saw you the pic. Now I show you the pic. No, so now if I am calculating Fibonacci of a particular number, the Fibonacci of a particular number will be calculated only once. For example, Fibonacci of 3 will be calculated only once, and after that, if again Fibonacci of 3 comes up, the result will be simply fetched from the array. So that will happen in here. We don't have to calculate the Fibonacci of things again and again. Now let's see how much time this is taking. Okay, let's see. We get the result instantly now. No, so we can now calculate the Fibonacci 50 also, and it won't just run and run and run. See, we are getting the Fibonacci of 50 also. So like this thing, the memoization is not like very tough concept to understand. We are simply storing the result somewhere, so that we could simply pick it up and use that result instead of calculating from an expensive function again and again. We could just pick up the result and use it. So yeah, like that simple the memoization is. But you can see now we are able to calculate the Fibonacci of 50 that we were not even able to calculate before. So yeah, it to make our function that much faster. Okay, so that's all for today's video, and in the next video I'll tell you how we'll use memoization inside React. We'll use the use memo hook for that. Okay, so yeah, in the next video we'll do that. And if you extracted any value from this video, I'll really appreciate if you could subscribe to my channel. So yeah, go ahead and hit that subscribe button, and we'll meet next time.